Hey viewers, well let's have some fun with this paper shredder, shall we? A good circuit board. Gonna go right way first, eh? Hey, look at that. Not a bad effort chopping components up, but actually does damage it's supposed to do to destroy things. Yeah, it's not the best paper shredder. It's just a cheap, nasty one. 0.8 amp current, 150 watt max paper shredder. Yeah, it cuts components off circuit boards. Got to go right to the end. It did a little bit of cutting for a cheap, nasty design. There's a switch there too. Go toward the edges of the strongest parts are. The motor's over here, so this will be the strongest bit right in there. Let this update and I'll plug this directly where that power board goes in case because that thing, I've got to go through the meter, see how much current it uses in the process. Have some fun with this thing. It's not as good as the Fellows brand, this is just a cheap nasty one. This thing jammed up so easily it's utterly useless. I even bent some of the blades. Cheap nasty old thing. Oh, let's give it a test now. Doesn't smell like it's under any stress. It's trying to. What I was like pressing. Ah, I think it overheated. It stopped. And the wheels aren't bent. It did a fair good job there. For a cheap shredder, I did something. Eating a shredded board, a stuffed board. Hello, you gonna wake up on me or what? Aww. Didn't trip anything out. Oh, hang on. You know what I did? No, because it's not plugged into that, you idiot. Well, the voltmeter says it's not chipped, so time for a teardown. I think it's had a little line filter and everything in it, so I might have to bypass all that in case one of those chipped out or burned out. Oh, she got hot. Oh, she's hot. Maybe the thermal fuse tripped on that motor. Oh, that thing's jammed the buggery. That's not turning. Maybe this does not want to turn. Plastic leak, yeah. This is not like the Fellows paper shredders. Not a very good quality one. Didn't get hot enough to burn out. Maybe it chipped the thermal fuse. Alright, ballast and variac time, power straight to the brushes on this little thing and finish it off. Let's pull it all apart and have some final fun with it. Let's shred the motor. There's a 2.5 amp fuse on this thing. It's blowing the fuse. That's why it died suddenly. Sneaky buggers, there's a fuse on this thing. Ah well. Let's just go straight to the brushes. No, it's not going to have much torque obviously, but it's not going to do much else. It's going to end more spectacularly by putting power straight to the brushes, so let's just do that. Blew the fuse. Yeah, let's do that. Oh, let's give it a test. Nothing seems to be happening. Alright, unplug safety first. Might have got open circuit and somewhere else. Alright, let's plug the valve back in and see if we get power. Hopefully that motor hasn't gone open circuit or anything. Okay, let's turn the power up. Alright, turn it down a bit. I'm going to run it on about 200 volts. Very carefully it is. Turn this thing over by hand. No torque there. Ah well, she's got no torque, just load. I should have taken the load off it before I completely total it. Let's unplug safety first, take the load off, because what happens is when you put power straight to the brushes on a brush motor with series field windings there, in other words a series motor, you must use a ballast, because you got 3 coils in series, the armature and the 2 field coils, so it's a 240 volt mains shared between those 3 coils or 3 loads in series, so they're taking 80 volts each. So in theory, why it would burn out, that's why I'm using the ballast. I'm putting 240 volts to an 80 volt coil, which is why it burns out and overloads so easily, which is why I'm using the ballast. And when you take the field, no field current means no torque. With the field, the stronger the field is, the more torque. But with no field at all, there's no torque. So I have to take that motor off and have no load on it in order to do this overspeed experiment. We'll see if my tachometer battery is not flat, and I'll do a drag race on it. Bloody tacho's gone flat. Oh well. It's going to be difficult to get a reading off this bloody thing anyway, so that's variation 0. Let's go again. Alright, turn it down a bit. I need 2 sets of pliers. One to hold the motor down, both heavily insulated. Safety first, I'm going to get this motor to start. Pile of junk's got no torque. How can I put it? It's shy, so to speak. Interesting. Some motors do turn, but this one doesn't want to turn at all. There we go. Unplug, well I won't unplug it yet. Yeah, unplug safety first. Turn it a little bit and see if there's any more coils that aren't open circuit yet. Turn it a bit. Another coil's gone. Then again, this motor was pretty stiff to turn, so it explains why it's not wanting to have enough torque to turn itself, overcome its own friction. I go again. There's a little more to go yet. Try and burn every set of coils out in this thing. Okay, try that again. See if there's not enough circuit in there, so to speak. I'll plug that back in. Vertex on 0. Plug back in. Oh, here we go. This was a slow burn out. Very slow burn out. Power. On 0, unplug safety first. Close inspection. Oh, it's a smelly old bugger. Stiff motor. So it burnt out at the brush end, I think. The coils smoked a little bit, but the weakest part was where they connected to the commutator. Yeah, the connections to the commutator, that's where they burnt out. Those little wires there, the links. Let's see if I can get to these field coils. I'll take that fuse out, bypass that fuse, and they've got one wire there, another wire to that coil on. So white wire and a black wire. So I've got to go tap into this wire here and this wire to burn this coil out. Let's do it. So that's the magic smoke. The heating element's not that hot either, because it's a low powered motor, so it's obviously not going to get very hot. Turn this up. Smoke, baby, smoke, smoke. Whew, there we are. That's one. Unplug safety first. My clip leads are okay. Alright, bag 0, plug that in. Thermal fuse and everything bypassed. Resistance is changing. Notice the sound that changes in the coil. Unplug safety first. Remove my clip lead quickly. Let's drop in front of the camera there. Okay. Look at that, burning for a while. This one had all the additional stuff on it. Tape it in there. Looks like I've got another inductor on this one. This one, alright. Let's drop in front of the camera again. Anyway, that was a nice little burnout. Haven't done one like that in a while. Thanks for watching.